Welcome back, guys. This is question 6.11, and the statement of this question is: a soft drink machine is regulated so that it discharges an average of 200 milliliters per cup. Okay, so the average is given. If the amount of drink is normally distributed with a standard deviation equal to 15 milliliters, so on the basis of it we are asked to find the questions given in part A, part B, part C and part D. So let us solve it first. So in solving it, let me first find here the given data, and in given data the value of mu, which is the mean, is 200 milliliters per cup. So 200 milliliters per cup. Okay, and the standard deviation, which is sigma, that is 15 ml. Okay, so this is the given data. On the basis of it, let me solve different parts of our question. So part A of it is: what fraction of the cups will contain more than 224 milliliters? Okay, so we want to find out the fraction of the cups which will contain 224 milliliters of the soft drink. Okay, so what is this? Basically it is the real life formulation of the questions which we have previously solved. So therefore, if we will neglect the milliliters, so what do we want to find out? We want to find out the probability that x, or the amount, is what? X is greater than 224. Okay, so in order to find this probability, we need to consult what? We need to consult the z distribution table. So therefore this value should be converted to the z value. So therefore, in order to convert it to the z value, we know that z is equal to x minus mu divided by sigma. So let me put all these values. So x is 224 minus mu is 200 divided by 15. Okay, so this would be 24 by 15. So let me have it here: 24 divided by 15, this is 1.6. okay, so 1.6. Therefore we want to find out the probability that x is greater than 1.6, but the formulation of the z table is basically on the basis of the x is less than or equal to 1.6. so therefore, in order to find it out, we have to find the value in the z table and subtract it from 1, and therefore we would get this value. Okay, so let me find it out. 1.6. okay, so let me move to the z table, and here the value 1.6 is where? Let me search for it, and 1.6 is, this is the 1.6, and this is the first column because this is 1.60. so therefore the value we will have is 0.9452. okay, so let me write it: 0.9452. okay, and let me subtract it from 1. So 1 minus 0.9452, so this is 0.0548, 0.0548, and this is around what? This is 5.5%. okay, so means the 5.5% of the cups will contain more than 224 milliliters. okay, so that is what, that is basically the solution of part A of our question. So let me remove it and let me move to part B. So in part B, what is the probability that a cup contain between 191 and 209 milliliters? So we want to find out the probability that x is greater than 191 and less than 209. okay, that is what we want to find out. So therefore this value is what? Let me call it z1 and let me call it z2. okay, and let me first find them, and then after finding them out, what would we get? It was, let me have it, leg x is greater than z1 and less than z2. so after it we would do probability that x is less than z2 minus the probability that x is less than z1. Okay, so we would do it. So therefore, in order to do so, we don't know the value of z1 and z2. So therefore, the value of z1 is x1 minus mu divided by sigma. Let me put the values here. So x1 is here 191, this is x1 and this is x2. So let me put these values. So 191 minus 200 divided by 15, so it would be minus 9 over 15. It is what? So 9 over 15, this is 0.6 or minus 0.6, and the value of z2 is x2 minus mu divided by sigma. So the value of x2 is 209. So 209 minus 200 divided by 15. So this is again 9 by 15 and this is plus 0.6. So therefore, we want to find out the probability that x is greater than minus 0.6 and less than 0.6, and therefore using the same formula which is here, we would have to find what? We would find the probability that x is less than 0.6 minus the probability that x is less than minus 0.6. Okay, let me find these values from the z table. So in the z table, 0.6 is how much? This is 0.6 and the value it has is 0.7257. So 0.7257 minus for the value of minus 0.6, it would be minus 0.6 is here, so it is 0.2742, 0.2742. okay, let me subtract them, and here it would be 0.7257 minus 0.2742. okay, so the value it has would be 0.4515. so 0.4515, which is around 45.15%, and that is what? That is basically the solution of part B of my question. Okay, so this is the probability and this is the percentage. Okay, as we were asked to find the probability, so therefore this is the answer. So that is for part B of my question. Let me remove it. In part C, how many cups will probably overflow if 230 milliliter cups are used for the next 1000 drinks? Okay, means the probability that x is greater than 230 milliliters, this is the threshold amount, and the amount which exceeds it is basically the overflown amount. So therefore it would be what? It would again be the conversion to the z distribution table. So therefore z would be equal to x minus mu divided by sigma. So x is 230, mu is 200 as given here. So 200 divided by 15. So this is 30 divided by 15, which is 2.0. Okay, so the value of z is 2.0. So therefore this is the probability that x is greater than 2.0, and as we know that z distribution is constituted in terms of the formula, which is x is less than 2.0. This is for the lesser value. So therefore, in order to find this value, we have to first find this one and then subtract it from 1. Okay, so let me find it out, this value. So it would be x is less than or equal to 2.0, because this is the continuous distribution, so we can use both of them. So let us consult our table. So 2.0 is where? This is the 2.0 and here the value is 0.9772. So 0.9772, okay, subtracting it from 1 minus 0.9772, okay, so this is 0.0228, 0.0228, okay. So this is the probability value x is greater than 2.0. Okay, this is a probability. In order to find the number of the cups which will overflow from the 1000 drinks, that would be what it would be the chance of the overflow multiply with the total number of cups, which are 1000. So therefore it would be 22.8, okay, so which is around 23 cups. Okay, so that is basically the solution of part C of my question. Let me move to part D of my question. In part D, we have to find that below what value do we get the smallest 25% of the drink. Okay, so that is part D, and this is what, let us find it. This is the distribution. This is the distribution we have, and the mean value of it is what, that is 200, okay, and the standard deviation it has is 15 milliliters. Okay, now we want to find out what we want to find, that what value do we get the smallest 25% of the drinks. So the lower 25% are, let me have here, okay, so let me have here the lowest 25%. So this is the lowest quartile or lowest 25%, and for it we want to find out this value. Okay, we want to find out this value, that lower than this we will have the less than 25% drinks. Okay, so therefore we have here what, let me have here the standard distribution. So for it, if we have x is less than x1 in this distribution, so in Z distribution, where we would have all of these in terms of what it will be here, and here the mean value would be 0, the standard deviation will be 1, and here we will have this Z1. Okay, we want to find out this Z value, so therefore it would be here, this is for this one, and for it we will have x is less than Z1, and this is what, again this is 0.25. okay, so this is 0.25, and for finding this Z value we would have to do what, it would be the inverse of 0.25. so let me find it in the distribution table, that what is the Z value which corresponds with this 0.25. so let me search for 0.25. so this is the value which is 0.2513. so the value it corresponds with minus 0.6, and the column value here is 0.7. so this is minus 0.7. okay, so the value of Z1 is minus 0.67, which is of this value. Okay, now in order to find out this value from it, what do we have to do? We know that Z is equal to x minus mu divided by sigma. So therefore the value of x is what, this is mu plus Z multiplied by sigma. We know the value of mu, that is 200. We know the value of Z, which is minus 0.67. okay, and the value of sigma is 15. okay, let me find it out. So it would be 0 minus 0.67 multiplied by 15, 0.67 multiplied by 15. so this is 10.05, and subtracting it from 200, 189.95, and that is what, that is basically the value which should be here, and that is the solution which we wanted to find. Okay, so that's it for today, in which we have solved question 6.11. If you have any question, you can ask me in the comment box. See you soon.